Today, I will be demonstrating Safeguarded Copy, a feature that provides immutable hardware-based snapshots on IBM Flash system storage. Immutable hardware-based snapshots are protected from accidental or malicious actions, such as deletion of backup data. In addition, hardware-based snapshots allow for extremely rapid recovery. There are a multitude of ways you may leverage Safeguarded Copy. In this particular demo, I've deployed a simplistic production environment along with a logical air-gapped disaster recovery environment. The demo will be in two parts. The first portion will cover a manual disaster recovery test and restore, along with a brief explanation of the underlying technology. The second portion is a practical deployment leveraging a tiny bit of automation, launching a disaster recovery test within a sandbox environment. This will allow us to verify the copy is good, free from corruption and malware. On the Flash system, data for the safeguarded copies are stored within a child pool designated with a safeguarded flag. There is a new concept of volume groups, the area where you assign volumes to the scheduling and retention policy. In this example, we have two volumes being copied every 6 hours, in which those copies are retained for 1 day. We can also view the copies associated with the volume, when they were created, and when they will expire. These two volumes are associated with my critical application located on my landing pad primary host as drive letters ENG. In the event of accidental or malicious activity, we can revert back to a prior point in time. To perform ad hoc backups, disaster recovery testing, or restore back to production, these operations are performed within the Copy Services Manager UI. Typically, when an environment is compromised, the first step is to preserve the evidence. Here, I'm initiating a manual backup for future forensic analysis. The second step is to identify the last known good copy of the data. It's best practice to perform these test recoveries within a sandbox environment as to not reinfect production or cause follow-on problems. We are mounting a prior point in time to my DR test host for further inspection. This particular point in time looks good. It's time to fix my production host. Since we will be overwriting the production volumes in the restore procedure, we must first place these volumes into an offline state. Restore will overwrite production volumes. For that reason, and many others, I highly recommend enabling a feature within Copy Services Manager called Dual Control. This passes all major actions to a second admin for request approval, further reducing the likelihood of accidental or malicious actions. Just one example of zero trust. Continuing on with the restore operation, this will initiate a background copy process overwriting production with a good copy of data. Once restored, we can bring the volumes back online. This concludes the manual steps involved in backup, disaster recovery testing, and restoring back to production. Now moving on to the second portion of the demo, a practical implementation. By introducing a little bit of automation, we'll drastically reduce the number of recovery steps involved and minimize the chance of user error. This segment will offer more entertainment as we will play the role of a malicious attacker and recovery administrator. The environment is fairly simple. The production host is running Microsoft SQL that is being safeguarded. The disaster recovery environment is isolated to prevent production from becoming reinfected. In addition to the disaster recovery host, I do have a Linux server that mounts the volumes as read-only to perform background malware scan during every DR test. My production host has a database called DrewDB, which contains a handful of rows listing cities and states. In addition, we have a guest book in which we will infect with the highly dangerous EICAR test virus. Now the machine is infected. Let's take it a step further. Going back to SQL, we will offline the database and corrupt the tables. DrewDB is no longer in a functioning state. As if that's not bad enough, let's take it to the moon. Diving into Registry Editor, I'm sure we could find some entries that aren't needed anymore. This production host is now officially hosed up. The operating system refuses to boot, the database is corrupt, and the system is infected. With simple automation, no need to go into the Flash system or copy Services Manager UI for DR testing or restores. I've written two scripts, both very similar, except one has an option to restore back to production. Let's find a good copy. Our first attempt will be from the most recent backup. My automation script powers down the DR host, refreshes the DR volumes with the data from this point in time, powers up the DR host, and launches a background malware scan. We can see the guestbook is infected, however, this point in time is bootable. The database may very well be in a functioning state. In theory, this restore point could be salvageable. I personally wouldn't trust it, so instead of going further, I'm going to cancel the restore and look for a point in time further back prior to infection. Relaunching the script, we will choose another point in time. This particular snapshot is clean, free of malware. Now we just have to ensure the operating system boots, SQL starts, and has valid data. These unclean shutdown messages are normal as safeguarded copies are crash consistent snapshots. Everything looks good. I'm happy with this point in time. Let's continue our restore back to production. My level of paranoia is quite high, so I've included triple redundancy checks in my script since restoring back to production is a destructive action. The production host is automatically powered off, volumes refresh with the clean point in time copy, and powered back up. We will perform one final check to make sure everything is as expected. Perfect. Production is back in business. It's best practice to regularly perform DR testing to ensure you can recover. So, in my example, cron automatically refreshes the DR host and performs malware scans every 4 a.m. That gives the SQL administrator an opportunity to perform daily testing if they choose. If malware is found, I'm notified via email. An event is sent to QRadar SIM tool for advanced correlation to other suspicious events where further automation could be triggered. I hope this demonstration was useful. Please reach out with questions or if you'd like to have a roundtable discussion anytime.